All right, guys, so let's talk about solving absolute value equations. We have been talking about the graphs of absolute values. It feels like forever, but we haven't really talked about solving an absolute value equation yet. So just a couple of things to remember. Remember that absolute value is a distance. Okay, what do we know about distance? We know that distance is always positive. Okay, now another couple of things to remember. You must never, ever, ever change the expression that is on the inside of the absolute value bars. Also, we can only solve the equation when the absolute value AV, when the absolute value expression is isolated. And we'll talk about what that means here in just a minute. We will need to set up two equations to solve after we've isolated, okay? And then also recognize that we're going to use the same expression, but we're going to be doing the positive and the negative, okay? So here's what all of that means. I'm going to work this example as we go through the steps, okay? So we have x plus 3, not x plus 3, x minus 3 is equal to 2. Now, the first thing we need is to isolate the absolute value equation, or expression, I apologize. So notice how the absolute value over here, there's nothing else outside of the absolute value. We don't have a coefficient in front. We don't have anything being added or subtracted at the back, okay? So that's step one. That's just making sure it's isolated. Now we're going to look at if it is set equal to a positive number. If your absolute value is a positive number, so like right here, 2 is positive, then you're going to end up with two equations to solve, okay? So the first equation is equal to exactly what it is, okay? So that means that we are going to split it up. We're going to look at x minus 3 being equal to 2. So that's going to be one of our equations. I'm going to go ahead and just draw a squiggly line to separate it. The second equation is going to be equal to the negative of that. So remember, it's distance. So if we're talking about being 3 spaces away from 0, well, there's 2 places on the number line that are 3 spaces away from 0. It is 3, positive 3, and negative 3. Both of those values have a distance of 3 away from 0. So that means that we are also going, again, we're going to use that same expression that is inside the absolute value, but it's going to be the negative of that. Then after that, so from here, we're going to go ahead and solve. Okay, so I'm going to go ahead and solve. Add 3 to both sides. So one of our solutions is 5. Add 3 to both sides. And the other solution is 1. All right. So here, example 1, we're going to use set notation because it's 2 answers. And it's going to be 1 and 5. Okay. So we'll talk about graphing in just a second because, of course, graphing, we're going to use Desmos. But first, what if the expression is equal to a negative number? If it's equal to a negative number, then you have no solution because the absolute value can't be equal to a negative. We can't have negative distance. Then if the absolute value is 0, then we're going to rewrite it without the absolute value symbol. So then it really is just one equation. So here we have one equation, and that's it. So we have three scenarios. One scenario where it's equal to a positive number or expression, and then we split it into two equations. Another scenario where it's equal to a negative expression or number, and there's no solution. There's nothing we can do. Then the other scenario is where it is equal to 0, and then we just have the one equation to solve, because 0 does not have a why can't I think a sign? All right, so let's look then at example number 2. Okay, notice that example number 2, that's really blurry. The absolute value itself is isolated. There's nothing in front, there's nothing behind. It doesn't matter what is inside of the absolute value itself is isolated. So we're going to go ahead from here and we're going to split it into our two equations. So we're going to have 2x plus 2 equals 4. Then we're going to have our 2 times x plus 2 equals negative 4. Okay. We'll go ahead and distribute. Subtract the 4. Divide by the 2. So in this case, we have x equals 0. And then over here, everything is the same, except that on the other side, now we're dealing with a negative 4. Okay, so x equals 0 and x equals negative 4. That's how that looks. So now let's look at how we can use Desmos to check our answers. All right, so we are going to first, okay, let me go back here really quick. Anytime we are going to solve by graphing, we have to put it in standard form, which means that we have to make it equal to 0, okay? So right here, this graph the equation to check your answers. Make sure you note that your equation needs to be equal to 0. So what that means is right here, we're going to have the absolute value of x minus 3 minus 2 equals 0. Okay, now looking at Desmos, we are going to type in the absolute value of x minus 3 minus 2. Okay, and notice we're looking, it's equal to 0, and remember with quadratics, the word zeros means solutions. So there we have our 1 and our 5. Okay, so our answer was correct. Now let's look at our next one. Our next one was, we had absolute value of 2 times x plus 2. And then we're going to move that 4 over, so minus 4. And again, if we look at those solutions, we have that x equals negative 4 and x equals 0. So that's how we can use the graphing calculator to check our answers. All right. So we're going to do one more example together in the video, and then we will stop and we will begin working independently where you can ask questions. All right. So we're going to go ahead. I want to skip to example number 4. There we go. Sorry. I want to skip to example number 4. Because I know y'all are all looking at it and you're like, oh my God, there's a fraction. What do I do? So what I want you to notice first here is that we have this 3 halves, and we can't solve it like this. what we have to do is we have to isolate the absolute value. So the way we're going to do that is we're actually going to multiply by the reciprocal. If we multiply by 2/3 on both sides, the 2's cancel and the 3's cancel. That leaves our x minus 2, our absolute value, isolated. And then 15 times 2 is 30, divided by 3, that's going to be equal to 10. Now from here, we're going to split it into two equations. We're going to have our x minus 2 equals 10, and we're going to have our x minus 2 equals negative 10. Solve both of those. All right, and let's go ahead and plug that into Desmos to check our answer. Okay. All right, so we have 3/2 times the absolute value of, what was that, x minus 2. And then we will move that 15 over. And looking at your zeros, you have -8 and +12, which is exactly where we said they were going to be. All right, that's the gist of solving. It's a brief little a brief little introduction to solving absolute value equations.